translating English to algebra. So it's going to be important to be able to take something written as an English sentence and to be able to pick out the math key phrases and to be able to do any sort of calculation, write any type of equation, inequality, whatever they may be asking. So essentially going from the English sentence to the math sentence. So if we look at exercise 1A, it says write a calculation and a result that represents a number that is 5 greater than 3. So if you just read 5 greater than 3, you would be misled. So it says write a calculation and a result that represents a number that is 5 greater than 3. So we want to say 5 plus 3. Okay, so there's your calculation with your number, with your result. Now it also says, part B says, write a calculation and a result that represents a number that is 2 less than 9. 2 less than 9. So we've got 9 minus 2. Do we agree that 7 is 2 less than 9? You certainly should. So this one says, write a calculation and a result that represents the sum of negative 3 and 8. So that key word, okay, sum. So we have negative 3 plus 8, and the result could be 5. Write a calculation and a result that represents the difference. So our key phrase, difference. So we know that to mean subtraction. 20 minus 12, which is 8. If x represents a number, write an expression that represents a number 10 greater than x. Okay, add 10 to x, and that certainly makes a number that would be 10 larger than x. If n represents a number, write an expression that represents a number that is 5 less than n. So now we got to be careful here, being that less than. Okay, it doesn't say is less than, it just says less than. So that's got to be n minus 5. When it says 5 less than a number, you have to think that it's subtraction. The order switches. Because if n were, say, 12, and we want to represent a number 5 less than 12, we'd have to say 12 minus 5, which then would be 7. Okay? So that less than, you end up changing the order. If y represents a number, write an expression that represents the sum, so key phrase, sum of y and a number 1 greater than y. So we've got the sum of y and a number 1 greater than y. So I would say you probably could write this a couple different ways. Y plus, we know we're summing, and then it says a number 1 greater than y. So a number 1 greater than y would be that. I put parentheses in it just to show that that shows a number 1 greater than y. Y plus 1 is 1 plus, or 1 larger than y, being added to that number y. If n represents a number, write an expression that represents the difference. Okay, so some keywords. Difference between a number 1 larger than n and a number 1 smaller than n. So 1 larger than n plus 1, difference, and a number smaller than n. Now this one you must have parentheses around that second group, that number smaller than n, because it's the difference between these two numbers. Okay, n plus 1 represents one number, and n minus 1 represents one number. So because it ends up being written as a binomial, we have to subtract that whole binomial from this binomial. That's why we've got to have those grouping symbols to represent that n minus 1 is that whole number. That entire number, I should say. Okay, so exercise 2 is same idea, but I think we're going to change some things up a little bit here. It says, write an expression for a number that is 5 times greater than 2. So instead of just adding and subtracting, we're going to throw some multiplication and division into the mix. So 5 times greater than a number, which would that be 10? If n represents a number, then write an expression for a number that is twice. Okay, twice, you know to be 2 times n. Letter C, write an expression for the quotient. Love that word. Quotient or ratio of 12 and 3. So quotient means to divide, and then ratio is also indicating division. 12 minus 3, which is 4. Then, oh, I should say, I shouldn't put that equal sign there because they did say write an expression. So an expression does not have an equal sign. So if I wanted to evaluate that, I should say 4. Same thing up here in A. It did say expression, so I'm not going to put my equal sign there. I'm just going to say, what is that value? It's 10. Back to D, if x represents a number, write an expression for the ratio of x to 5. So when you're talking about ratios, x to 5, that means x divided by 5. You may also see ratios written with the colon, x to 5. These are the same thing. Okay. Next page. Got some more translating to be done. If x represents a number, then write an expression for a number that is, so now we're including some more things, 3 more than twice the value of x. So I would say translate it word for word. Whoops, not in, there we go. 3 more than twice the value of x. Standard form says to put the x term first, so 2x plus 3. These are equivalent, they're the same, but standard form says always put your x term first, then your constant on the end. If n represents a number, then write an expression for 2 less than. 2 less than 1/4 a number. That less than indicates subtraction. Okay. This one, the order absolutely does matter. 1/4 a number, 2 less that. So subtract 2. Must be in that order. If S represents Sally's age and her father is 4 years less than 5 times her age, then write an expression for her father's age in terms of S. So let's find those key words. Her father is 4 years less than 5 times her age. That less than, okay, so the order is absolutely going to matter here. So 5s minus 4. If x represents a number, then write an expression for 3 times the sum of x and 10. So think about that for just a moment. 3 times the sum of x and 10. X and 10 have to be summed, but we've got to multiply 3 by that whole sum, so I need to put that in parentheses. Then represents a number, then write an expression for 7 less than 4 times the difference of n and 5. 7 less than, okay, 4 times the difference of n and 5. So 4 times the difference of n and 5, 7 less than. Okay. Letter F, we're using x, then write an expression for the ratio of 3 less than x to 2 more than x. Okay. The ratio, so we've got division. Okay. 3 less than x to 2 more than x. Okay. X plus 2, that's the 2 more than. Okay. And that's all minus 3. Right? Then we've got letter G, talking about x. Then write an expression for the sum. Get my highlighter back out here. The sum of twice x with twice a number 1 larger than x. So the sum of, so I know I'm going to add something, twice x with twice a number 1 larger than x. So the number that I'm going to multiply by 2 is 1 larger than x. If n represents a number, then write an expression for the quotient of twice n with 3 less than n. Quotient, here's my math words that I need. Okay. So quotient, I know I'm going to divide twice n with 3 less than n minus 3. Talking about y, then write an expression for 3/4 of the difference of y and 8. So we know we've got the difference of y and 8, and we've got to take 3/4 of that number. And then x, write an expression for 1/2 the sum of x and 4. 1/2 the sum of x and 4. And I've got to take 1/2 of that sum. Let's go back to F just for a minute. I'm not real pleased on how I wrote that and or how I explained it. So I'm going to erase F for the moment. And all this is good that I highlighted. So the ratio, so I know I mean division, of 3 less than x, 2. So there's the 2, that's my division. So 3 less than x means x minus 3, to 2 more than x, x plus 2. There we go. That looks a lot better. Okay, sorry about that. And last one. Neat patterns can occur repeatedly when you play around with numbers. Love this kind of stuff. I think it's so cool. Fairly easy one occurs when you add a number to 1 less and 1 more than your number. It says do this for a few numbers, x, and record the results. Then prove a general pattern by writing an expression for the sum of a number with a number 1 less than and number 1 more than. Okay. So some number. Okay, so I'm going to start out with something pretty basic, and I'm going to say, okay, number 1. So, whoops, my stylus will let go of that 1. There we go. And we add a number 1 less than it, which would be 0, and a number 1 more than it, and we add those two, we get 3. Okay, pretty basic. What if I go to, I don't know, maybe if I go to 4. So if I pick the number 4, and I add the number 1 less and the number 1 more than 4, so that gives me 12. All right, let's do it again, and let's do, I don't know, 10. Number 1 less and a number 1 more. Add those up and get 30. All right, we can't forget about the negatives. So I don't know, let's pick -1. So the number 1 less than -1 is -2, and the number 1 more than -1 is 0, and add those up and we get -3. Oops. Lost my stylus here, guys. Had a little technical difficulty there. Sorry about that. Had to pause and figure out what's going on. All right, so in this first example, the one I wrote in black, x was 1, and the sum came out to be 3. The next one, the sum was, or excuse me, x was 4. Oh, so having technical difficulties here, guys. I apologize. 12. Then the third one, the sum was 10, and it came out to be 30. So now we're going to look at patterns as we go through this. So then this last one, the sum was -1. Can't seem to find my stylus. -1. The x was -1, and the sum was -3. So what kind of patterns do we notice? 1 to 3, and 4 to 12, and 10 to 30, and -1 to -3. Hopefully you're noticing that it's 3 times x. So now, that's kind of cool that that happens. Let's see, algebraic expression. So now let's talk about it in general. So what if we pick some number x and we add, I'm losing my stylus, that's why it's getting all wacky on me here. Can't tell where I'm writing. Alright, so x plus a number 1 less, so x minus 1, and then a number 1 more, x plus 1. So if we combine like terms, we end up with x plus x plus x, which is 3x, -1 plus 1 gives me 0. So look what happens. Algebraically, when you take a number and add a number 1 more than it and 1 less than it, you get 3x. And we did it back here, just sort of playing around with some numbers, and we saw that same pattern. And then that would lead me to say, let's see if I can write it, I love math patterns. All right, you guys are done.